What's up? Welcome to Models and Agents, episode 31. It's April 15th, 2026. Let's see what happened in the AI world today. And trust me, it's been busy. Google DeepMind's Gemini Robotics-ER 1.6 upgrade delivers enhanced embodied reasoning and instrument reading for real-world robot control. If you are building physical AI systems, this one is worth your attention. What you need to know today is that DeepMind released Gemini Robotics-ER 1.6 as a high-level reasoning model focused on visual-spatial understanding, task planning, and success detection for physical robots. Several new agent protocols and infrastructure projects also launched targeting autonomous agent commerce and on-chain coordination. Pay attention to the wave of new reasoning evaluation techniques and production-grounded agent benchmarks that better reflect real deployment challenges. Let's start with the top story. Google DeepMind released Gemini Robotics-ER 1.6. An upgraded embodied reasoning model designed to act as the cognitive brain for robots in real-world environments. The model specializes in visual and spatial understanding, task planning, success detection, and instrument reading. Those capabilities are critical for physical AI systems operating beyond simulation. Compared to prior versions, the 1.6 release brings measurable gains in reasoning depth required for complex manipulation and environmental interaction. Practitioners building robotics applications can now integrate this as the high-level planner while pairing it with lower-level motor control systems. Early adopters should test it on instrument-heavy tasks, where previous models struggled with accurate reading and sequential planning. I am genuinely excited about this because embodied reasoning has been one of the hardest gaps to close. Watch for broader rollout across DeepMind's robotics stack and potential integration paths with existing robot operating systems. Now, on the model updates front, researchers introduced something called Filtered Reasoning Score. Filtered Reasoning Score evaluates reasoning quality only on a model's top K% most confident traces rather than averaging across all outputs. This approach differentiates models that achieve similar benchmark accuracy but differ substantially in faithfulness, coherence, utility, and factuality. Models with higher filtered reasoning score on one benchmark tend to transfer better to others in both accuracy and reasoning quality. The team open-sourced the evaluation codebase so you can start using it immediately in your own experiments. Next, there is a new training method called Self-Distillation 0, or SD0. SD0 turns binary rewards into dense, token-level supervision without needing an external teacher model or high-quality demonstrations. A single model alternates between generator and revisor roles, then distills the revisor's improved outputs back into the generator via on-policy self-distillation. On math and code benchmarks using Qwen 3-4B instruct and Olmo 3-7B instruct, it delivered at least 10% gains over base models. It also outperformed rejection fine-tuning, GRPO, and self-distillation fine-tuning under identical compute budgets. The method shows clear token-level self-localization and iterative self-evolution, which is pretty cool to see. Then there is the CURE framework for long-form factuality. CURE teaches large language models to reason about uncertainty at the individual claim level. It uses a claim-aware reasoning protocol that pairs atomic claims with explicit confidence estimates. A multi-stage pipeline first aligns confidence with correctness, then optimizes for factuality. This enables selective prediction where the model can abstain on uncertain claims instead of hallucinating. It improved claim-level accuracy by up to 39.9% on biography generation. It also increased AUROC by 16% on FactBench while preserving recall. That is a serious jump in trustworthy long-form generation. Shifting over to agent and tool development, CROO officially launched the CROO agent protocol. This creates decentralized commercial infrastructure specifically for autonomous AI agents to conduct commerce. The protocol aims to power reliable agent-to-agent and agent-to-human economic interactions without centralized intermediaries. Developers building agent economies should monitor the protocol for integration points in decentralized marketplaces. It feels like another step toward truly autonomous economic agents. Lithosphere also released infrastructure enabling autonomous agents to perform on-chain coordination and decision-making. The platform focuses on reliable blockchain-native coordination primitives that agents can use for collective action and resource allocation. Teams working on decentralized autonomous organizations or on-chain agent swarms now have new tooling for production-grade coordination. This could accelerate real on-chain agent swarms in meaningful ways. Finally, in this category, Gupshup launched Super Agent, an autonomous AI agent built for large-scale customer conversations across messaging channels. The system handles complex, multi-turn customer service interactions with minimal human oversight. Companies running high-volume support operations can deploy it today for conversation orchestration at scale. That is a practical win for anyone drowning in support tickets. On the practical and community side, a community member named Evil Engineer released an experimental merge called Quopus 3.5 to 27B-V3-RYS-uncensored-fernflower AI-KL-RELU-GGUF. It is based on Qwen 3.527b and optimized for local agentic programming with tools like clawcode or z.dev. The model combines uncensored weights, RYS layer duplication, and fixed SSM conv1d tensors for better long context stability. Q80 and Q4K GUF quants are available on Hugging Face. It ships with an updated chat template that includes tool fixes and a deep thinking system prompt. If you have an RTX 3060 or similar, this is worth downloading for local experiments. Researchers also introduced Alpha-Eval, a production-grounded benchmark of 94 real tasks sourced from 7 companies deploying AI agents. It covers 6 ONET occupational domains and evaluates complete agent products against implicit constraints, heterogeneous documents, and evolving expert standards. Unlike synthetic benchmarks, this one reflects actual deployment pain. The accompanying requirement to benchmark framework helps organizations rapidly convert authentic production requirements into executable evaluations. That could save teams months of evaluation engineering. There is also a new method called Thought Retriever. Thought Retriever is a model-agnostic approach that retrieves and reuses an LLM's own filtered intermediate thoughts from past queries instead of raw data chunks. This bypasses context length limits while maintaining a self-evolving long-term memory of useful thoughts. The memory grows more capable with continued use. A new benchmark called Academic Eval tests faithful use of ultra-long academic paper contexts. The method showed at least 7.6% F1 and 16% win rate gains over baselines. Now let's pop the hood on something interesting that ties a lot of these reasoning improvements together. Everyone talks about best of n selection as if majority voting or simple probability averaging magically surfaces the best answer. In practice, radial consensus score reveals that semantic geometry carries far more signal than discrete counts or raw logits. The core insight is to embed candidate answers, compute their weighted Frechet mean as the geometric center of mass, then rank each answer by its radial Euclidean distance to that center. This turns consensus detection into a continuous geometric operation rather than a combinatorial vote. Different weighting schemes, whether uniform, frequency-based, or model probability, plug directly into the same framework without retraining. The efficiency comes from operating in embedding space rather than token space. Radial consensus score adds negligible overhead yet consistently outperforms self-consistency and probability baselines. The gains widen as the sampling budget grows from 4 to 64 candidates. It also serves as a drop-in replacement inside multi-agent debate loops. The gotcha that bites most teams is assuming all embeddings are equally calibrated. Poor embedding models collapse the radial signal. The quality gain is most pronounced on long-form reasoning where surface-level agreement diverges from semantic correctness. Use radial consensus score when you have at least 8 to 16 samples and care about robustness over raw speed. Skip it for tiny sample sizes or when your embedding model has not been tuned on your domain. In those cases, fall back to probability-weighted selection. If you have not tried Gemini Robotics-ER 1.6 on instrument reading and sequential manipulation tasks, this week is the time, especially if you have access to DeepMind's robotics APIs. The embodied reasoning improvements hit exactly where prior models fell short. Download the Quopus 3.5 to 27 BV3RYSGGUF quant and run it locally in LM Studio with the provided deep thinking system prompt for agentic coding experiments. It is ideal if you want an uncensored 27 billion parameter class model on something like an RTX 3060. Run alpha-eval style evaluations on your own deployed agents using the new requirement to benchmark construction framework. It dramatically shortens the gap between lab benchmarks and production reality. Experiment with Thought Retriever on long academic PDFs or internal knowledge bases. Watch how the self-evolving thought memory improves over successive queries. Compare radial consensus score against majority voting on your existing best-of-n pipelines. You can implement the Frechet mean ranking in under 50 lines and measure gains on long-form reasoning tasks. On the horizon, expect broader ecosystem adoption of order-aware hypergraph retrieval augmented generation techniques as more teams realize set-based retrieval fails on temporally sensitive reasoning. Watch for production deployments of SD0 and cure-style self-calibration methods in math, code, and long-form generation pipelines. Several labs are likely to release updated agent memory benchmarks that incorporate the new production-grounded evaluation paradigms introduced this week. Continued community experimentation around locality-aware, sparse attention for blockwise diffusion language models could yield practical speedups on consumer GPUs within the next quarter. Before we go, tomorrow keep an eye on how these production-grounded benchmarks start showing up in more open leaderboards. That wraps up today's AI briefing. Share this with a developer or builder who wants to stay current. Subscribe wherever you listen. See you tomorrow. This podcast is curated by Patrick, but generated using AI voice synthesis of my voice using ElevenLabs. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy, and I hope others do as well.